Hey guys, today in this video we are going to discuss about Euclid's division lemma and Euclid's division algorithm. But before that, let me tell you some facts about Euclid. So Euclid was a Greek mathematician and he was known as founder of geometry or father of geometry. He was died in Alexandria in Egypt and his nationality was Greek. He was born in mid of 4th century and he is known for his Euclidean geometry, Euclid's elements, and Euclidean algorithm. So now let us discuss about lemma. A lemma is a proven statement used for proving another statement. Means a statement which is already proved but which is used to prove other statement is called a lemma. Suppose there is a statement, let every even number can be divided by 2. You all know about this, that every even number can be divided by 2. Now, this statement can be used to check whether a number is even or not. Suppose you have a number and you divide it by 2. So if this number is completely divided by 2, so you can say that this number is an even number. Or if this number is not completely divided by 2, so you can say this is not an even number. That means this statement that every even number can be divided by 2 is a lemma. So now Euclid's division lemma. According to this lemma, if you are given two positive integers a and b, then there exist unique integers q and r which will satisfy the equation, that is a equals to bq plus r, where r is less than b but greater than or equal to 0. In simple language, you can say it dividend equals to divisor multiply quotient plus remainder. Suppose you have a number a and you divide it by another number b. If you have a number a and you divide it by another number b, then you will get a quotient, and after the division you will get some remainder. So now this remainder will be less than b. This remainder will be less than b and greater than or equal to 0. So we can write it as a equals to b multiply q plus r. A equals to b multiply q plus r. So this statement is called Euclid division lemma. You can understand it by an example. Suppose you have two numbers 17 and 3 and you want to divide 17 by 3. So now when you will divide 17 by 3, you will get 5 as quotient and you will get 2 as remainder. So now here 17 is our dividend and 3 is the divisor, 5 is the quotient, and this 2 is remainder. So now you can write 17 as 17 equals to, you can write it as 17 equals to 3 multiply 5. 17 equals to 3 multiply 5 plus 2. Because you all know that 3 multiply 5 is 15, and when you will add 2 in 15, then 15 plus 2 will be 17. Okay. So in this division, you can say 17 as a, 3 as b, and 5 as q, and this 2, this is remainder, so this will be r. So this is the Euclid's division lemma. Now we will discuss about Euclid's division algorithm. But before that, let us understand what is an algorithm. So an algorithm is a series of well-defined steps which gives a procedure for solving a type of problem. Suppose you have a problem and you want to solve it. So to solve the particular problem, you will need at least 2, 3, or 4 or more than 4 steps. So the set or the series of those steps will called as algorithm. means if you have a problem and you want to solve it. So the collection of all steps which are used to solving that problem, the set of those steps will called as an algorithm. Now, Euclid's division algorithm. Basically, this algorithm is used to find the HCF of two or more numbers. So, to obtain the HCF of two positive integers, say C and D. Suppose you want to find the HCF of two numbers which are C and D, and where C is greater than D, then you have to follow the steps. First of all, step 1, apply Euclid's division lemma. Means you have to divide the number C by D. So we find whole numbers Q and R. Means when you will divide C by the number D, you will get a quotient, say Q, or a remainder, means R. Now this R will be less than D but greater than or equal to 0. So by using Euclid's division lemma, we can write it as C equals to dq plus R. C equals to dq plus R. Means when you will divide the number C by another number D, because C is greater than D. So you will get a quotient Q and then a remainder R. So you will write C equals to dq plus R, and here we are using Euclid's division lemma. So this remainder, according to Euclid's division lemma, this remainder R will be less than D but greater than or equal to 0. And if this R equals to 0, means after division you will get 0 as a remainder, then you can say D is the HCF of C and D, because if you divide C by the number D and you will get 0 as a remainder, so you can say D is the HCF of C and D. But if the R is not equal to 0, means if the remainder is greater than 0 and this is not equal to 0, so you have to again apply this step. You have to again apply Euclid's division lemma, and you have to continue this step until you get the remainder 0. So the collection of all these steps will called Euclid's division algorithm. Let us understand it by an example. So if you want to find the HCF 420 and 130 by using Euclid's division algorithm, so you can say clearly that 420 is greater than 130, so you have to divide 420 by 130. So on division, when you will divide 420 by the number 130, you will get 3 as your quotient and 30 as your remainder. You can say clearly that after division, the remainder is not 0. Remainder is not equal to 0. Remainder is 30. So again you have to divide, again you have to repeat this division. So in the first division, means in this step, you have to write it by using Euclid's division lemma. Means you will write 420 equals to 130 multiplied by 3 and plus remainder, that means 30. And now because the remainder is not equal to 0, so you have to again repeat this step. You have to write 130 as the dividend. Now you have to use this 130 as the dividend, and you will have to divide this 130 by the remainder of first step, means you have to divide it by 30. So when you will divide 130 by the number 30, you will get 4 as quotient and the 10 as remainder. So for the second step, again by using Euclid's division lemma, you have to write 130, means the dividend is equal to divisor multiply quotient, means 30 multiply 4 and plus remainder, that is 10. Okay, and you can see clearly that the remainder is not 0. Still the remainder is not equal to 0, so you have to again repeat the division. Now you will write 30 as the dividend. You have to write this 30 as the dividend, and you have to divide it by the remainder of second step, means you have to divide it by 10. So when you divide 30 by 10, you will get 3 as quotient and 0 as remainder. You will get 0 as remainder. So now you can stop it here. Now you can stop it here because you will get 0 as the remainder, and you will have to write the third step of division as 30, means the dividend equals to divisor multiply quotient, that is 10 multiply 3, and plus remainder, that is 0. So you can see here, after dividing by 10, after dividing by 10, we get the remainder 0. So we can say 10 is the HCF of 420 and 130. So here you can see, here you can see there are three steps of Euclid's division lemma. Here are three steps of Euclid's division lemma. So the collection of these three steps has become the Euclid's division algorithm. So when you have to apply Euclid's division lemma more than one times, so the collection of all those steps will become Euclid's division algorithm.